Hello guys, today we're going to learn an on and about air and water. Let's go. This is a mind opener. So when we climb high mountains such as Mount Everest, why do they carry cylinders for breathing? And like when in an aeroplane, its doors and windows are sealed. You're not allowed to open that window at slightly also. But why is that so? We're gonna learn on and about atmosphere. It's the blanket of air that surrounds the earth is called the atmosphere. So there are few types of atmosphere. There are five atmospheres, which are troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Ozone layer is located in stratosphere. In simple words, it's the blanket of the earth. Atmosphere is nothing but. So, importance of atmosphere, it provides a necessary gas for living things to survive. It plays an important role on the water cycle. Ozone layer protects the earth from sun's harmful rays, support protects and supports the life. So the layers of the atmosphere are, as I told, troposphere, stratosphere. Troposphere is where living beings are here, blah blah blah. So troposphere, stratosphere, mesosphere, thermosphere, and exosphere. So the troposphere is nothing but it is the first and the lowest layer of the Earth's atmosphere. So it extends up to around 15 kilometers above the surface of the Earth. This is only the layer where the living things can live and grow. Mostly weather changes there only in this layer. That's troposphere. So the stratosphere, as you can see here in the picture, there is an ozone layer. It's where it protects us from UV rays, which is ultraviolet radiation. So this is an altitude here, as you can see. So stratosphere, it extends up to 20 to 50 kilometers above the ground. Less dense, less water vapor. The temperature increases with altitude to 0 degrees Celsius. Almost like no weather occurrence contain high level of ozone. Ozone layer is there, and upper boundary is called as stratopause. So we can also get knowledge on what is an ozone layer by seeing this Dr. Bannock's video. So now let's move on to mesosphere, which is it extends almost up to 80 kilometers high. The gases are less dense. It stops meteorites to enter into lower layer, and the temperature decreases around minus 100 degrees Celsius as altitude increases. Gases in this layer absorb very little UV rays. Let's move on to the thermosphere. Thermosphere is nothing but the above mesosphere and extends almost up to 550 km, it's kilometers high. Temperature increases with altitude. So readily absorbs the solar radiation. Temperature can go as high as 1000 degrees Celsius. Reflects radio waves, as you can see here. So the exosphere, exo means outer, and the outer portion of the thermosphere it reaches from about 400 kilometers outward of thousands of kilometers. Like space shuttles and satellites orbit here. You can see a video here. So now let's see the components of air. The nitrogen is the most, the oxygen is the second most, the argon is the third most, and the fourth one is carbon dioxide. So let's move on to deeply. So there is there are many different types of gases in the atmosphere. They include nitrogen, oxygen, argon, carbon dioxide, and other noble gases. A nitrogen and oxygen make up to around 99%, and these other gases, which you can see here, the nitrogen is, as I told, it is 78.03. The oxygen is 20.99, which you can round finger as 21. 100, which is 21. A carbon dioxide, which is CO, which is 0.03. The hydrogen is the most, lesser thingy. It's like 0.01. The argon, which is A, can call it, which is 0.94. It's just the round figure. Don't think it's the correct answer. So next one is the properties of the air. So air occupies space, as you know. One of the riddle is what occupies the room. It can be light or air. One of the riddle. So like air is everywhere, but you cannot see it. You can feel the air when the wind blows or when a fan is on. An empty cup or an empty glass is not really empty. It is filled with air. Air occupies space, and here is an easy way to show that air occupies space. So here there are some videos you can check out here. One is this. One is this. And lastly, this. So using air pressure, you use a straw to drink cold water. A cold drink, you use a straw to drink cold drink from a bottle or from a glass. How does it work? So when you suck in, the air in the straw, the air pressure inside the straw decreases. So the air pressure on the surface of the drink is now more than the air pressure inside the straw. So this force the drink into the straw and your mouth. So like an easy words to say, it vibrates, something like that. So when you pump air into the tire of your bicycle, it gets harder due to the increased air pressure. So this allows you to ride the bicycle comfortably. So try let some air out from your bicycle tire and ride what happens. So you'll just like fall down, not due to no air in one of the tires. So air is needed for burning also. So to fix two small candles on a table, cover one with candle glass. Why does the flame go after a few seconds? Why does it uncover candle keep burning? So you can try this activity where you just like lit up a candle, put a glass on top, which has to be higher than candle. Then you might see the candle burning off. It got off. So atmospheric pollution. What is a pollution? What is air pollution? As you already know, air pollution is harmful material into the atmosphere, causing damage to living organisms and to the environment. Like for example, global warming, everything like that. So causes of air pollution, major sources of air pollution are like high proportions of unreversible industries, automobile and domestic fuels, gases such as sulfuric dioxide and carbon monoxide. Dust, smoke and harmful gases make up dirty air, or polluted. This pollution of atmospheres caused mainly by release of smoke and poisonous gases from the factories, vehicles So when the fossil fuels such as coal and oil are burnt in the factory, or when petrol is burnt on the vehicle, the poisonous gas given out is called pollute in the air. It is given out. So here, as you know, what is water? It's an important natural resource, essential for all living animals, plants, human beings. So it is an element, essential element where there is an existence due to it because we can only survive through it. So we all use water for drinking and other household activities such as cleaning, washing, cooking, bathing, and etc. etc. So it is also used for irrigation, general electricity, irrigation in the fields, and any other electricity stuff like hydro power, something. So where can we get water? So about 97 of the water from Earth's surface is the world's oceans. This is where you can find most of the 3%. So the 3% of it is lakes, rivers, rain, polar ice caps, clouds, sea ice, and stored in rocks. There are some water stored in rocks. So solution. So it's where when you mix solute and solvent, you get solution. So solute plus solvent is equal to solution. So solution is the mixture formed from the substance dissolved in it. So solute is nothing but it's a mixture. It's like, for example, you can also try this. Take on anything. I mean, take like pepper, salt, sugar, or a color, and then mix it in a clean water and you'll get the solution. So solute is the substance that dissolves and solvent is the liquid in the solution. So dissolve means the mixing of the substance in the liquid. Soluble means a substance which can dissolve. So insoluble means a substance which cannot dissolve, like a plastic can't dissolve in water. So it is an insoluble, but soluble, which is sugar, salt, pepper. No. Yeah, pepper that can mix in the salt. In the water. So removing insoluble impurities. So insoluble impurities in the water can be removed by the following methods, mainly which is decantation, sedimentation and decantation and filtration. So sedimentation is nothing but separation of two components in which way that the heavier substance settle down. So as you can see here, the lighter and heavier object, the first one which is the how can I say, it is oil. It's oil, and that is underneath the sand. It is water, or you can maybe call it a sand. So the oil is really lighter. You put as much as in the water, but it's still lighter. So sedimentation is the process of settling down the heavier particles present in the liquid mixture. Decantation is the process of separating two liquid components of the mixture while the solid component has settled at the bottom of the sediments, that is transferring a liquid from another container. Here, decantation. So it's a separation of two components, where such as taken oil. We can take an example of oil and water that do not mix well from each other. So like oil and water do not mix. Oil just like floats and the water sinks. as we learned the density chapter, so like that. So for example, the separation of the oil and water while the water settles down and being heavier than oil. So as I told, um, the top layer which is then separated by decantation. So I have one activity for you guys. So maybe you can try it out. You can take sand or pepper, then you can take a filtration paper or fine cloth or tape, for filtering you use. So you can take that, and you can just take 2 glasses with one filled water and one with pepper. One with pepper. Yeah. So just put the water inside, mix it well. Then after that, when the sand or the pepper settles down, then you just put the water inside the glass and then leave leave the leave the pepper down there. Don't put it again inside. So as you can see there, then it will be a separation which is called decantation. So sedimentation means where that sand just went below and then settled down. Let's see how sedimentation decantation happens. As I told, take a transparent glass, fill half of the glass with water and add sand or pepper. Keep it for some time. What would you observe? And after some time, transfer the above layer to other glass. So then it will come filter. Now we'll filter it. So filtration, separation of the solid from liquid either by using filter paper or any strainer, fine cloth or strainer. Like for example, separating tea from the tea leaves, using a strainer, or separating mud from water using filter paper. So then filtration is used to separate like insoluble items. As I told, insoluble means it's where it can never dissolve. So the funnel, take a funnel and put the filtration paper, put in the water, and you'll get it inside. As you can see, all the particles, muddy particles, or the whatever the insoluble items would be here. So you can see here one of the videos here, and you can do it. So removing soluble impurities, we have learned now how to remove insoluble. Now how to remove soluble. So pour some salt water in a beaker and heat it. If you hold cold steel plate on top of the dish, you will find the steam condenses, form droplets. You know droplets, right? So these droplets are a pure water. So free all the soluble as well as insoluble impurities. You will notice some like salt left behind in the dish after the water has evaporated. So this method of evaporation followed by condensation is used to remove soluble impurities from the water. This, whatever the thing is called, distillation. So you can also watch this video on it about that, how to remove impurities. Soluble impurities, yeah. So drinking water. So you know about drinking water. It's like at home, water can be boiled around 15 to 20 minutes to kill the germs, right? So we then filter it. So the substance called alum is also used to purify water. So many several like water purifiers are available in the market for home use. Some use of a special kind of light called ultraviolet light to kill germs. Other use special filter that can filter out bacteria. The town water supply uses water from lakes and rivers. This water is purified in the water work to make keep safe for drinking. So they do so much work for keeping the water safe for drinking. So this is how it gets filtered. I won't be reading this all that, so I'm just gonna explain you. So they take muddy water and they put for some steaming. Like they would just mix it, and then they would just mix everything and then throw it here. So all that muddy water will be here. Okay. So then it will go inside like this and then come here and it will get filtered. It will go here. While it is going here, there will be chlorination process. Chlorination process is nothing but it is added very small amount to kill the germs. A tiny bit is only added for this huge amount of water, because in when you add so much, then you might die due to too much of chlorine thingy. So it gets stored here. I mean, it'll get chlorine. I mean, it'll get chlorine there, and it'll get stored here. Everything. Then after that, water supply will happen. Like these are the houses. So yeah, that's all. That's all from me. Thank you so much, guys. Hope you like it. Hope you understood. And I will show you the process of that activity. Before I'm gonna show you how it has to be done. And yeah, that's all. Thank you. Bye.